An AI agent just debugged your production bug. No restart, no redeploy, no SSH session. It placed a probe inside your running container and captured the broken variable. This is HyperProbe, a YC-backed tool that launched 3 days ago. It binds debugging hooks directly into your node.js runtime and captures variable snapshots from live production traffic. The standard move when production breaks is to add console logs, push a new build, wait for deployment, and hope the bug happens again. That cycle costs you 30 minutes minimum. And it gets worse. Full heap snapshots can double your memory footprint and trigger killers. Traditional debuggers block the event loop and freeze every request behind the breakpoint. Here is what a heap snapshot does to node.js. Creating one requires memory about twice the size of the heap at the time the snapshot is created. If your heap is 4 GB, you need 8 GB free. It is a synchronous operation which blocks the event loop for a duration depending on the heap size. Most containers do not have that headroom, so the process gets killed mid-snapshot. So let's take it apart. HyperProbe runs as an agent inside your container. When you place a probe, it opens a session with the V8 Inspector API and registers a breakpoint at the target line. Here is the node.js Inspector API. You create a session, connect to the V8 Inspector, enable the debugger domain, and post a set breakpoint command with script ID and line number. The actual Chrome DevTools Protocol message looks like this: method debugger.set breakpoint, a location with script ID and line number, and an optional condition that filters when it fires. But here's the problem. CDP breakpoints halt the event loop by design. When the breakpoint hits, the entire JavaScript thread freezes, blocking every other request queued behind it. This is how traditional debuggers work. HyperProbe claims it does not pause the event loop. The hook executes and detaches in under 15 microseconds. For context, event loop monitoring typically flags blocking over 100 milliseconds. Here is how it works. The probe fires on the next matching request. The agent captures the variable tree asynchronously, out of band. The request continues without blocking. The snapshot uploads after the response has gone out. Every probe is created with an explicit lifetime and a hit limit. The default is 1 hour and 1 snapshot. When the clock expires or the hit count is reached, the probe clears itself automatically. Now, the safety boundaries. The agent monitors event loop lag and heap memory continuously. If lag exceeds 15 milliseconds, or free memory drops below 15%, the cooldown shield activates and purges every probe instantly. The cooldown shield monitors event loop utilization. That is a metric from libuv, the C library node.js uses. ELU measures CPU time spent in the event loop. When utilization climbs above 85%, the agent purges all probes. PII redaction happens in process before the snapshot is compiled. The agent scans for sensitive property names and strips them inside your container. The payload never leaves your memory boundary with credentials intact. But here is the trust boundary problem. The filter is a string match, not semantic understanding. The redaction list is fixed. Password, token, cookie, credit card. Anything named outside that list gets captured in full. Quick recap. HyperProbe binds to V8 Inspector, captures variable snapshots without blocking the event loop, and auto-expires after 1 hit. Now the AI part. HyperProbe exposes its engine via the Model Context Protocol. MCP is an open standard from Anthropic released in November 2024. Claude Desktop, Cursor, and Windsurf all support it. Instead of building custom integrations, you implement MCP once. The MCP handshake looks like this. The AI assistant sends tool discovery. HyperProbe responds with available methods. The assistant calls set breakpoint. HyperProbe confirms. The assistant polls get snapshot. HyperProbe streams back the capture. The workflow is autonomous. You paste the error into Claude. The agent scans your codebase to find the file and line. It identifies webhooks.ts line 78 as the handler. It connects to the broker using MCP, injects the probe, blocks on the telemetry queue until a live request hits, reads the captured state, and identifies the broken parameter. Status equals pending with no handler. Most teams are capturing snapshots inside 15 minutes of starting. Probes and captures are unlimited on every plan, because nothing about debugging should be metered. You do not pay per probe or per snapshot. So how does this compare to the old move? Traditional debugging requires a redeploy, push to CI, build, rollout, downtime risk. HyperProbe is 0 seconds. You place the probe, and it is live inside the running container. You are guessing where to log. You add 5 console logs, redeploy, and hope one catches the bug. HyperProbe places the probe in production, captures on the next request, and the exact variable state is already there. The overhead claim is less than 1% at 3,000 requests per second. That is the total system overhead, not just the hook execution time. That overhead comes from 3 places. The hook itself fires in 15 microseconds. The snapshot serialization happens asynchronously, so it does not block the request, but it does consume CPU cycles, and the upload to the broker happens out of band. HyperProbe also supports the JVM via runtime bytecode manipulation. That is a fundamentally different mechanism from V8 Inspector. Java agents use the instrumentation API, attach API, or bytecode rewriting libraries, all more invasive than V8 Inspector. The documentation says runtime bytecode manipulation for JVM, but does not explain which instrumentation technique, whether a startup flag is required, what the hook execution time is, or what the overhead looks like. That is a gap for anyone evaluating HyperProbe for Java. Quick recap. HyperProbe binds to V8 Inspector using the Chrome DevTools Protocol. It captures variable snapshots without blocking the event loop, and it exposes the whole engine to AI agents via MCP. 3 takeaways. The honest part. HyperProbe solves the redeploy loop and the event loop freeze, but the trust boundary is a string filter, not a semantic PII detector. The CDP non-blocking mechanism is not explained in the public docs. How do they turn a blocking CDP breakpoint into a 15 microsecond non-blocking hook? And the JVM bytecode story is undocumented. Powerful tool. Gaps remain. HyperProbe launched 3 days ago. If you try it, check what API key captures. Links below. Subscribe for more.